Okay, click and close for me, please. I want to just show you something very briefly, and then we're going to do just a little bit of board work. Half of you and the rest of you can be working in between. I know you're trying to get your little stuff all wrapped up, which is great. Okay, so I added one very, very short assignment. It is, I think it's 8 questions long. You can probably do it, and I'd be surprised if it takes you 10 minutes. It's not a big deal. Here's what it's about, though. It's stuff we already really talked about. We did lots of practice on kind of the types of problems that you see in a math book, the ones that work the way they're supposed to. But I want to give you just a little bit of practice with some problems that don't really work the way they're supposed to, right? Where the answers are a little bit more subtle. You got to look at them and very easy algebraically, but you got to interpret what's the simplest form of the solution. We'll look at just 2 examples and you'll get what I mean. So this is an AND statement, right? Everybody sees that the OR is the V. If you flip an OR statement, it becomes an AND statement, right? So you flip the symbol, it turns into an AND, because AND and OR go together, right? So we've got this AND statement here, this compound inequality, easy to solve. Let's take this one first, that part. What are the 2 steps to isolate the x? Subtract 5 and then divide by 2. See if you can do the mental math on that. What's that going to give you? If I subtract 5 from 19, I get 14 and I divide by 2? 7. Okay, so I'm going to get an x on this side and a 7 on that side. Was there any reason to flip the inequality? No, I divided by a positive, didn't I? So I'm fine. So one solution is x is greater than 7. And what about the other side? Let's do this one now. Same thing. Really simple math. You can do this one in your head probably. What are the 2 steps in order to isolate the x? Add 6 and then divide by 4. So 18 plus 6 is 24 divided by 4? 6. Okay, so we end up with x is greater than 6. Okay. Once again, no reason to flip the inequality. Okay, now look at that statement. Something's weird about that. Think what that says. X is greater than 7 and x is greater than 6. If you put it in like that, it's going to mark it wrong because it's not simplified. We can say that more simply. How? But let's graph it. It might help to graph it, first of all. Let's try that. So if we graph this, we've got numbers at 6 and 7, right? So graph the blue inequality for me. What does that look like? Open and shading in which direction? To the right. Okay, what about the red? Open, shading to the right. Okay, so if it is an AND statement, this is what's important. If it's an AND statement, think back to the questions I asked you in class. We talked about heights, right? There was something important that came out of that. It's an AND statement. How many of the statements must be true for the compound statement to be true? And. Both, right? It's an AND statement. All of the statements must be true, right? So if I said you are, I want all the people who are taller than 5'10", who are wearing blue, and who are wearing blue, and who are male, well, that's going to be, all those things would have to be true for you to raise your hand. Right? Does that make sense? Okay. So what are the values up here based on the graph then? What are the values that are going to work for both statements at the same time? Would it work? Does 5 work for both of them? No. Does 6.5, 6.5 work for both of them?
I don't know.
Only works for the red one, doesn't it? Does 7.5 work for both of them?
Yeah.
Yes. Okay. So then what would be, let's combine the red and the blue into purple. And you tell me what's going to be the simplest way to find the solution of that AND statement. What would it be? All values greater than what? 7. Yeah, everybody see that? So this is the combined solution. That's the only place where both intervals intersect. When we talk about an AND statement, we're talking about an intersection. Right? That make sense? So when is x greater than 7 and greater than 6? Only when it's greater than 7. So that would be the correct answer. Okay? So all this stuff would combine into just x is greater than 7. Okay? Now, what if that had been an or statement instead? If that had been an or statement, so we'll go down here a little bit. What if we had made the statement instead, x is greater than 7 or x is greater than 6? How many of the statements must be true for an or, a compound or statement to be true? Only one, right? Raise your hand if you are taller than 5'8" or shorter than 5'8". Everybody's hands would go up, right? Because only one of those things has to be true. Okay? So what would the answer then be? What would the solution be? When is x greater than 7 or greater than 6? When x is what? No, greater than 6, right? Because that would be true for 6.5, wouldn't it? Right? 6.5 is greater than 6 or greater than 7. It's greater than 6. That's all that has to be true, right? So for this one, we would have gotten a solution. X is greater than 6. See my point? Okay. One more problem, real simple one. And then we can get to business here. Same kind of deal. This is an or statement, isn't it? Yeah. Right? I've got a B in the middle, so it's or. Yes, sir.
Can I leave for a cross-country meet?
Yeah, do you need to go now?
Yeah, we leave at 12:15.
Oh, yeah, go then. Yeah, absolutely. Good luck. Okay, what about this one?
Happy birthday.
Your birthday too?
Yeah.
Oh man, you got away today. It's a given. Okay, what about this? 2 steps in order to isolate x. Subtract 6, which gives us 34 minus 6. 28. Divided by 4, so we get 7 going. So we get x is less than or equal to 7. Or add 6, you get 12, right? Divide by 3, you get what? X is greater than or equal to 4. Okay, so let's try that. Look at that one. If I look at an or statement is not an intersection. An or statement is a union. So it's everything combined, right? They don't have to intersect. It's where either one of them is true. Okay? So we get numbers at 4 and at 7. How do I graph x is less than or equal to 7? Closed circle going to the left. Okay? How do I graph x is greater than or equal to 4? Closed circle to the right. Okay, so what are the x values that are true for either one of those? What x values would be true for either the blue interval or the red interval that exists, what would that be? Say it again. Any number. Yeah, right. So the answer is all reals in that case. Okay, everybody see that? Okay, you got the idea. So I put this assignment up just a little bit early because I've noticed that there are a number of people who are done with everything. So if you're done with everything, you can't really go on to 1.6 until we learn it next week, but you could do 1.7 if you're looking for something to do to kind of get something productive done. So that's one you can get out of the way.